It is all your fault we got kicked out of the single men's Winter Olympics. Now they have taken our skates and are making us do this test on the ordinary least squares regression.
Shut up, McElroy. If we pass this test we get to compete in doubles. Anyway, you couldn't even hold my junk sweat in men's singles.
I could hold them all day. Try me.
Maybe I will.
Maybe you should.
You challenging me, princess?
Okay, stop. We need to work together on this one. The ordinary least square estimator is a tough subject. Have you learned it?
That's one thing you don't know about me, McElroy. I might be a sex addict, but I'm also a keen economist. Listen and learn. The OLS is a method used in regression analysis, which is the study of how one dependent variable can be affected by one or more independent variables.
Okay, can you give me an example of these variables?
Sure thing. Think about the amount of competitions we win and how many hours we put into training. Have a look at this graph. The results speak for themselves. As you can imagine, the more hours we train, the more we will win. In regression we assume the y variable is random in some way. However, we assume that the x variable have fixed values in repeated samples.
Okay, so this equation you have written on the board, I think I recognize it. Is it an equation for a straight line?
Finally, Jimmy, you have a brain. Yes, this is an equation we will use to draw the line of best fit. Y equals alpha plus beta x. This model will tell us with certainty what the value of y is for a certain x value. So Jimmy, do you get me so far? We need to ace this test.
Yeah, you're a good teacher, Chaz.
This is what the line of best fit will now look like. But Jimmy, this isn't fully realistic, and so we will add a random disturbance term, u, into the equation. This is what the equation will look like. The alpha and beta values are chosen so the vertical distances between the data points and the fitted line is minimized. The OLS means taking the distance from the data points to the fitted lines, then squaring this. Then we would minimize the total sum of the area of the squares. Do you follow me?
Yes.
We can see from this graph, y acts as the actual data point for observation, t, time. Y hat symbolizes the fitted value from the regression line, with u hat is the residual, and is the difference between y and y hat. The closer this value is to 0, the more accurate the regression is. This sum is called the residual sum of squares and can be denoted by the equation on the whiteboard.
But wait, how do I work out alpha hat and beta hat, and what do they mean?
Ha ha, I thought you might ask that. Alpha hat represents the intercept on the y-axis and beta hat is the gradient of the line. They can be found using the following equations.
I think I can remember these. Hey, I think I'm getting the hang of this.
Now, there are 4 assumptions we need to learn regarding the classical linear regression model. These generate the residual terms and give the error terms the following properties. The first one being zero mean. 2. Constant variance over all x values. 3. Independence from one another, and 4. Independence from the corresponding x variable. If these 4 assumptions hold true, then the estimators alpha hat and beta hat we determine using the OLS are better known as BLUE.
Best, linear, unbiased, estimator.
Best means that the OLS estimator beta hat has minimum variance along the class of linear unbiased estimator. Linear is where beta hat is a linear estimator. Unbiased is on average. The actual values of the alpha hats and beta hats will be equal to the true value. Estimator is where beta hat is a point estimate of the true value of beta. So Jimmy, if you listen carefully and we look over this stuff again, we will have the OLS test nailed.
Woo! I love you, Chaz Michaels.
Okay Jimmy, but in return, in our first skate off, we're dancing to one song, and one song only, Lady Humps, by the Black Eyed Peas. What you gonna do with all that junk? All that junk inside your trunk? I'ma get you drunk, of my lady humps. My humps, my lovely lady humps.